Hey, everybody. So I just wanted to do a quick little overview of today's worksheet, do a couple problems with you guys, and then I'll let you complete it on your own. So I guess, first thing, if you want to print this out or if you want to do it on Cami or do your work on a separate sheet of paper, however you'd like to do it, is fine with me. Just make sure you're showing your work on every single one of these problems. Okay, on the front side of this worksheet or the first page, is all of them are asking you to find the missing side of the triangle. All right, but the little thing I added here is these will all be perfect squares. Okay, so these will all be problems that at the very end of it, you'll get something like the square root of 25, which is considered a perfect square because it gives you a nice clean 5 as your answer. Okay, that's just an example there. Okay, use your calculator when in doubt on these if you don't have these perfect squares memorized. Okay, I'm going to leave these to you because the second page is doing the same thing, but these ones are asking you to leave your answers in the simplest radical form, meaning they're not going to be perfect squares, or at least not necessarily. And I want to remind you how to simplify those radicals. Okay, so let's start on, let's do number 9 together, and then I'll probably do one more with you guys. Let's take a look at number 9. Okay, so maybe the biggest thing on this entire worksheet is how do we find the missing side length of a right triangle? Well, this is all about the Pythagorean theorem, right? This is what we learned in our lesson prior to this worksheet. So this is what you might want to just copy at the top of your worksheet or wherever you have room. I'm going to put it over here. So yeah, just a reminder, the way I taught Pythagorean theorem is that it's c squared equals a squared plus b squared. Okay, and A, B, and C are just the 3 side lengths of a right triangle. Here's the big thing to remember. C is a specific side. Okay, plugging in C has to be the hypotenuse of your right triangle. If you want to leave yourself a little reminder, that has to be the hypotenuse, which, by the way, the A and B are the legs of the right triangle. Those are just the other 2 shorter sides of the triangle. Okay, but the big thing, the hypotenuse. Okay, just remember, the easiest way to find the hypotenuse is it's always opposite your 90-degree right angle. So if you draw an arrow across from it, it will always point at the hypotenuse of your right triangle. Okay, so on this one, number 9, I have to plug in 8 for C. So that's where I'm going to start. Okay, A and B are just the other 2 sides. It doesn't matter which you plug in for which. I normally make the smaller one A and the next bigger leg B. Okay, so yeah, getting your numbers in the right spot, really important. From here, this math isn't too difficult, right? Again, grab a calculator if you don't know how to do some of this. 8 squared gives me a 64, 4 squared gives me a 16, plus x squared. Okay, from here, I'm solving for x. I have these 2 numbers to get rid of. I'm first going to get rid of 16. It's being added, so I'm going to subtract. All right, 64 minus 16. Looks like I'm going to be getting 48 on the left, x squared on the right. Okay, be careful. We're not done yet. We have not solved for x. We now need to get rid of this squared. Okay, and if you guys remember, we have to do the opposite operation. Okay, the opposite of squaring a number, if you remember from the lesson, is square rooting. Okay, those are opposites. Whatever I do to one side, I have to do to the other. Okay, so that is canceling out. I like to put a little cross through just to show, okay, square root and the power of 2 are canceling. I'm going to be left with x on the right here. Okay, well, I'm gonna keep that erased for now because what I need to do now is simplify the square root of 48, which actually I'm gonna bring it over here. Okay, so I got the square root of 48. Okay, not a perfect square. You could type that into your calculator, but you would get a decimal. And we don't want decimals on these, at least not on this worksheet. Eventually, we might just use the decimals. But for now, we need to. I want you to practice how to simplify these. Okay, so what we're gonna do is we're gonna break them down into their prime multiples. Okay, what that means is I'm trying to figure out what are all of those small prime numbers that multiply to get you a 48. Okay, it sounds confusing, but it's really simple. The first thing we need to do is just think of what 2 numbers multiply to get 48. Okay, there's a few options. There's 2 times 24, there's 4 times 12, there's more of them. Whatever comes to mind first, do it. Okay, I'm going to just, because it's even, I know that 2 times half of 48, which would be a 24, okay, works. But if you want to use some other numbers, that's fine. Okay, here's the thing. 2 is prime. I cannot break down a 2 anymore. Okay, 24 is not. So I can keep going on this thing. Again, there's options. I can do 4 times 3. I'm going to do 2 times 12. Okay, another thing to remember, when you're breaking these down, I recommend putting your smaller numbers on the left, bigger numbers on the right. When you break a number down, cross it out. That 24 does not exist anymore, right? It's a 2 times 12 now. Okay, 2 is prime. I'm going to break down the 12 though. 2 times 6, cross it out. Again, 2 is prime, 6 isn't. Break it down. 2 times 3, cross it out. Okay, 2 is prime and 3 is prime. I cannot break down a 3 anymore. Okay, so what I just did is I broke this thing down into its prime factors. If I were to multiply 2 times 2 times 2 times 2 times 3, I would get 48. Okay, so why did I do that? Well, this is what we're looking for. Pairs of numbers. Pairs of numbers get to come out of the radical sign. Things that do not pair up stay inside. And when I say pair, I mean 2 of the same numbers. Okay, so I'm looking through and I'm noticing, oh, I have a pair of 2s. I'm going to circle them. Okay, I notice I have another pair of 2s. I'm going to circle them. Okay, this 3 though does not pair up. That means I like to put a line underneath it to show that it's staying in the radical. All right, so this is actually going to give me my answer. So this pair of 2's here means that a 2 comes out of my radical. Okay, this other pair of 2's means that another 2 comes out of my radical, and they're being multiplied. What stays inside is what didn't pair up, a 3. Okay, and now one more step, I can multiply these together. So this got a little messy here, but I'm going to go ahead and write x equals 2 times 2 gives me a 4, square root of 3. Okay, so there is the answer they're looking for. That is the simplified radical form. Square root of 48 and 4 square root of 3 are the same thing. They represent the same number. This is just a simplified form of it. Okay, so yeah, good thing to know just because this pops up ever so often asking you to simplify. Okay, I want to do one more with you guys. I want to do one that gives you some of these weirder square root numbers. So let's see if I can find a good one here. Yeah, let's do number 13 together. Okay, so again, Pythagorean theorem, c squared equals a squared plus b squared. Plugging in my c value, taking a look opposite my right angle, looks like that's my c value. So I'm going to plug that in 2 square root of 2. Okay, oh, and don't forget, that's being squared. The whole thing's being squared, so I'm going to put parentheses around it. If you don't put parentheses, by the way, it's implying that only this square root of 2 would be getting squared, just by the way. Okay, a and b are the other two sides. I'm going to make the square root of 2 my a value, and my b value is going to be x, what we're looking for. Okay, so this looks scary, but if you guys remember from the lesson, it's not. Because the nice thing about squaring and square rooting is they often cancel each other out. All right, here's the first thing, starting with this here. This power of 2 needs to be applied to both of these numbers in here. So I need to square this 2, which would give me a 4. And then I need to square the square root of 2. Remember, square rooting and squaring cancel, and I'm just left with what's underneath the radical there. So I'm actually just going to be left with a 2, okay, and they're going to be multiplied. Okay, the same thing is happening here. The square root and the power of 2 are canceling, and I'm just left with the 2. Okay, and then plus x squared. Okay, and you notice now we're left with something that's not bad, right? Let's go one more step real quick. Let's multiply this. So I get 8 equals 2 plus x squared. Okay, now I can solve here. I'm going to subtract the 2 first. Okay, so I'm getting a 6 equals x squared. Let me erase this. Okay, and then yeah, last thing, to undo the square, I'm going to square root. Let me try that again. And I'm going to do that to both sides. Okay, here's the thing. They want the simplest form of our radical. So let's go ahead and try to simplify the square root of 6. Again, I'm thinking 2 numbers that multiply to get 6. Well, in this case, there's only one option, 2 times 3, right? Here's the thing. These are both prime numbers. I cannot break them down anymore, right? And remember, after we break it down into the prime numbers, we're looking for pairs of numbers to come out of the radical, and I do not have any. There's not a pair of 2's, there's not a pair of 3's, so these are staying inside the radical, or in other words, the square root of 6 is already completely simplified. Okay, so just remember, sometimes radicals cannot be simplified any farther, and that's your answer. Okay, so there it is. I'm going to get x equals the square root of 6. Okay, so yeah, if you can do those two problems I just did, the rest of them are even more straightforward and simple. I did the two ones I thought were the hardest problems. Okay, so yeah, go ahead and work on this. Make sure you're showing your work on every single problem. Okay, hop into the meet if you have questions. See you guys.